All right, guys, we're on to video number 2. So just a reminder that you are taking notes on these videos. The videos on every day will always have the same title from video 1 to video 2. So we are still on the same title, 1-1 patterns. Right here on your paper, you took notes on video 1. So now we're going to take out our pencil and we're just going to get started on notes for video 2. So you're taking notes on the same piece of paper. Again, same title, same paper. No need for a next paper. In this video, we're going to focus on that first word from the title, which is patterns. So we're really going to try to figure out, given a list of number, what is the patterns? How do we get from the first number to the next number? We're going to do this by creating a table of numbers. Within each table, normally, we only have 2 columns. We have, if you're thinking of graphing, we have an X column and a Y column. Now, the X column would be considered your input. I have a number that I'm starting with, and I'm inputting it into a process. Your Y number would be considered the output. So we're going to actually make 3 columns in today's tables. We're going to have our input, which we normally think of as our X. We're going to have our output. We normally think of that as a Y. But then we're going to have to figure out, how does the first number get turned in to the second number? What's the process? What's an algebraic expression that will allow us to change our first number to our second number? So again, today's patterns will have 3 columns: our first number, our last number, and the process in the middle of how to get there. We're going to do a total of 2 examples. Now, don't forget, you're writing this in your notes. So go ahead and pause the video so you have time to copy down this table, and then we'll talk about how to do the table. All right, just a reminder that our first number is our input. In the middle, we're going to figure out the process. What kind of math do we need to do to get to that last number, which is our output? Okay, so we started with a relatively simple one, I hope, for you guys. If we're looking at just the top row, I'm starting with the number 1. I do some math, and then I get the number 0. Now, the trick to these problems is, whatever math you do to the number 1 to make it turn into a 0, you have to do the same math to the number 2 to change it into a 1. You have to do the same math to the number 3 to change it into a 2, and so on. So the process always has to be the same. You can't decide that you're going to times the first one by 0 and subtract the next one by 1 and multiply this one down here by 1/5 or something like that. So just got to make sure that the process is always the same. And again, this one is a little bit easier, so hopefully you've already discovered what the pattern is. But basically what we're doing is we're taking our input number and we're subtracting 1 from it. 1 minus 1 is 0. I'm taking my input number and I'm subtracting 1 from it. Taking my input number and I'm subtracting 1 from it. So the pattern is I'm always subtracting 1. You do, again, want to make sure the pattern holds true for all of them. And then when we get down here, I'm going to keep going with my pattern, but I don't have an output yet. So I'm going to have to figure out what the output is. The output is going to be 4. 5 minus 1 is 4. Right here, 6 minus 1 is 5. Okay? So that is what, let's see if I can move this. I cannot. I'm going to hide it. Okay. So that is how to figure out the pattern. So we want to have the 3 columns. We have our input, we have our process, the math that we're doing, and then we have our output. Now, for the very, very last row, I've changed it from a number into a variable. And so now the question is, given any number, not knowing what the number is, I don't know if it's 5 or 10 or 5 billion, what is the process? And so basically what we're going to do is we're going to take, in each of these processes, we had our input number. It was the 1, the 2, the 3, and so on. And so we're just going to take all of those numbers, and instead of writing that number, we're going to write the letter N instead. Now this minus 1, that stayed the same every time. So I'm going to keep that, and I'm going to say N minus 1. So the process, no matter what number in the world I'm given, I'm always going to take that number, N for number, and I'm going to subtract 1 from it. And that's what will give me my output. Okay, so this is how we deal with patterns given a table. Now, again, this one was a little bit on the easy side, relatively easy, not too bad. And so next, for our second example, we're going to do one that's a little bit trickier. So I'm going to try to make it super tricky so that you can do those really difficult problems. And then this next one will be our last example for today. So go ahead and pause, take a minute to write this down, and then we'll get started. All right, guys. So now we're going to do a second example. This one is going to be significantly more difficult than that first one. That first one was just a, like, let's get started. But we're going to try to do a really tricky one now, because if we can do the really tricky ones, then hopefully we'll be able to do our homework. Okay, so this one, that's pretty tricky. And the reason why it's so tricky is because we don't really know, like, the pattern's not super obvious. In our first example, it was pretty easy. We subtracted 1 every time and we got from our input to our output. In this problem, I can't add and subtract the same number to get from my input to my output every time. If I look at my first row, to get from 1 to 2, I would add 1. But I can't really do that on my second row. To get from 2 to -3, I'm not going to add 1. I'm going to subtract 5. So it's not the same pattern. And to get from 3 to -8, again, I'm going to have to subtract, 11 that time? So the pattern's not very consistent. I am looking for a very consistent pattern. So my pattern is not just like adding or subtracting the same number each time. It's also not multiplying. So if I look from 1 to 2, that's timesing by 2. Pretty simple, pretty straightforward. But if I do my next number 2 times 2, well, that's not -3, that's 4. 3 times 2 is not -8. And so again, I can't really just say I'm always multiplying by the same thing. It's a little bit trickier than that. So if you're looking at a table and you're just like, you're lost. You're like, I don't even know. I can't figure out what the pattern is. What I like to do next is I like to kind of ignore the input column and I'm going to focus just on the output column. And I'm going to try to figure out what the difference is from one output to the next. Okay. So if I'm looking at my first one, 2 to -3, to get from 2 to -3, I had to subtract 5. Now, hopefully, we're going to cross our fingers that that's the same pattern for the next one. So to get from -3 to -8, I also have to subtract 5. I'm starting to see a pattern now. To get from -8 to -13, I'm also going to have to subtract 5. And so right now, if I really wanted to, I could predict what the next number is going to be. I'm going to hold off for a second on that, but I could try to figure out what the next number would be. All right, so my pattern is going to have something to do with subtracting 5. Now, it's actually not going to have to do with subtracting 5. -5 is actually going to be a multiplier. So whatever the difference is from one output to the next output, that's what you're going to end up multiplying by your input. I'm going to multiply by -5. I'm going to multiply by -5. I'm going to multiply by -5. And so each time I'm going to multiply by that -5. Okay. Now, obviously, that doesn't give us the right answer. That's going to get us partway there, but not all the way there. So right now, if I take my 1 and I multiply it by -5, that's going to get me down to -5. But I want to be at +2. So now the next thing I'm going to do is I'm going to figure out a number that I can add. Okay. So -5 times 1 is -5. -5 plus something's got to get to 2. Well, 7 minus 5 is 2. So I'm going to add a +7. And then the question is it's got to be the same number for all of them because it's supposed to be a pattern. So let's just check and make sure. -5 times 2 is -10. And -10 plus 7 is -3. That works. -5 times 3 is -15. And -15 plus 7 is -8. So I think we figured out our pattern. I think our pattern is that I'm going to take my input number. I'm going to jump down here to my variable. I'm going to take my input number, n, and I'm going to times it by -5. And then I'm going to add 7. So let's check and see if that works for the number 5. So in theory, what I should be able to do is I should be able to do -5 times my input number of 5. And then I should be able to add 7. So -5 times 5 is -25. -25 plus 7 should be -18. And then we just want to double check and make sure that the pattern holds up over here. -13 minus 5 is -18. And we're good to go. We figured out the pattern. Okay. And then on that last one, you're always just going to like repeat the -5n plus 7. That's what gets repeated in the output. And let's just check and make sure that we did it correctly. So sometimes the pattern is going to be pretty obvious and you're going to be able to just like stare at it and it's going to work. But other times the pattern is not going to be very obvious, and you're going to have to do a little bit of investigating to figure out what the pattern is. All right, guys, so make sure you wrote all this in your notes. This one does have some homework problems assigned to it. You can look in the directions to the video to see what the homework problems are, and I'll see you tomorrow.